Howdy, y'all. I'm Matt, Chief of the Flutter Bounty Hunters. At the Flutter Bounty Hunters, we're a team of developers that work exclusively on open source Flutter and Dart packages. And a critical aspect of building great open source packages is a great philosophy towards testing. And that's what we're going to talk about here today. We're going to talk at a high level about software testing and somewhat more specifically about testing your Flutter code. We're going to talk about what a test is, why do we write tests, and some of the strategies we can use to write effective tests. Let's jump into it. First, what is a software test? Every developer knows that they're supposed to write tests, but rarely do developers ask themselves, what exactly is a test? What goals am I trying to accomplish by writing tests? We're going to answer these questions. And we're going to start with a metaphor. And actually, this is the wrong metaphor. This is a bad metaphor. You don't want to use this one. You see, the word test is a bit misleading. The word evokes the idea of quizzing your code to see if your code produces the right answers. The quiz metaphor then leads developers to think that tests determine whether your code is right or wrong. But this perception of software tests is fundamentally misguided. Your tests have no idea whether your code is right or wrong. So I'm going to give you a different metaphor, another metaphor you can lean into that better reflects what you're trying to accomplish when you write software tests. Instead of thinking of tests like quizzes for your code, think of tests like security chains around your code. You take your source code, you wrap these test chains around your source code, and then you lock them down. That's what tests are all about. To appreciate the metaphor, consider a bike that you store outside overnight. Every night you chain up your bike. Why do you do that? You chain up your bike so that you can rest assured that when you step outside tomorrow, your bike will still be exactly where you left it. Between the moment you chain up your bike and the moment you remove the chain, you can go anywhere and you can do anything, and you know that your bike is where it's supposed to be. We chain up code for the same reason. Once we get a piece of code working the way we want, we chain it up so that our desired behavior doesn't change in the middle of the night. Those chains around our code, they don't tell us whether our code does the right thing or the wrong thing. They only guarantee that our code does the same thing as it did when we chained it up. Another way of saying this is to say that we write tests to lock down aspects of our code so that it can't change without getting a developer's attention. This is what tests do. This is why we write them. It's not because a manager told you to write tests. It's not so that you can hit some magical number called 100% test coverage. It's not because your tests know the difference between right and wrong. These are all somewhat misguided attempts at effective testing. At the end of the day, we write tests to lock down aspects of our code so that it can't change without getting a developer's attention. Let's talk about types of tests. Here again, let's lean on our metaphor. In the real world, we have different types of chains. We have short chains and we have long chains. We have thin chains and thick chains. We choose the chain that's best suited for the job. We'd like to be able to lock and unlock the chain as easily as possible, but we also need we need the chain to protect our property while we're gone. You can imagine that the strength of the chain in the lock around a little personal diary is quite a bit different than the chain around a $1,000 street bike, which is different than the chain around the gate to a $100 million property. Different objects, different value, different criticality. It means we choose different chains. Similarly, in the world of software, we have different types of tests. Now, some tests are easier to update than others. Some tests run more quickly. Some tests are less flaky. We'd like to use the test that's the least flaky, the easiest to write, and the fastest to run. And to do that, we first need to acknowledge what kind of code we're locking down. The kind of code that we're locking down can be thought of as a scope, a test scope. In theory, there's an infinite variety of possible scopes. But in practice, in the world of app development, we tend to run into the same set of test scopes over and over. Those scopes are user journeys, painting, user interactions, protocols, and units. We'll describe each one. A user journey is the broadest scope. It captures an entire feature within an app. Typically, a user journey spans multiple screens, hence the term journey. User journeys are often described explicitly in product specifications that come from design teams. For example, a design team at a bank might send you a specification that describes a series of screens that help a customer deposit a check from his or her phone. Once you've implemented this user journey, you might choose to wrap the whole journey with a test. That's a user journey test. Now, on the positive side, user journey tests are able to lock down a lot of details within a small number of tests. Also, a user journey test tends to lock down details that the product team cares about getting right. On the negative side, user journey tests tend to include a large amount of code per test. If you continue to do any work on the tested feature, you'll need to update user journey tests frequently. And they often require either a fake implementation of web services or they use real web services, which then make them flaky. Then we have a painting test, otherwise known as a golden test. A golden test is a test that locks down the actual pixels that are painted by your Flutter code. You might choose to lock down the pixels for a single widget, an entire screen, or an entire user journey. As a result, there is some conceptual overlap between a golden test and a user journey or user interaction test. However, the purpose of a golden test is to verify the final pixels, rather than verify any user input or navigation along the way. On the positive side, a golden test gives you a lot of bang for your buck. In just a few lines of test code, you can lock down every visual detail in your widget, your screen, or your user journey. Instead of manually inspecting every position, margin, width, or text run, a pixel comparison automatically ensures that all those details remain the same. All you need to do is manually check and verify the very first golden file that you generate. Because again, tests don't know the difference between right and wrong. So first, you generate the bitmap, you generate the pixels, you look at it, and you say, yes, that's what I want. And then from that point forward, any difference in the pixels will trigger a test failure and get your attention. Now, on the negative side of these golden tests or painting tests, absolutely any change to the widget, the screen, or the user journey that you lock down with a golden test will cause the golden test to fail. Sometimes these changes aren't even related to your work. For example, Flutter's rendering system might change the way that shadows are painted or the way that text anti-aliasing is implemented. These irrelevant changes might break all your golden tests, forcing you to revalidate each test. User interactions. User interactions refer to the effect of user input on an app, screen, or individual widget. For example, in Super Editor, our open source document editor, when a user double taps within a paragraph, the word that the user tapped should become selected. In other words, single tap places the caret, but a double tap selects an entire word. A test that locks down this double tap behavior would be considered a user interaction test. On the positive side, user interaction tests lock down details that the product team cares about getting right, and user interaction tests tend to contain relatively little code per test. User interaction tests also run very quickly. On the negative side, user interactions tests, they cover relatively granular features, which means you'll need quite a few tests, a large number of user interaction tests. Also, testing with gestures can be a bit tricky because you need to simulate the appropriate gesture, which includes careful control over the passage of time and the generation of fake touch events. That can be a little difficult to get right. Protocol tests. Protocols are the first test scope that we're looking at. that no longer has any direct connection to the product specification. A protocol is any contract between a set of related objects. As such, the protocols in your code are determined by your internal API design. It's based on how you break down roles and responsibilities. For example, imagine that you're a developer working on the Flutter framework, that you're actually on the Flutter team. The Flutter framework is heavily based on the relationship between three special types of objects: widgets, elements, and render objects. Widgets talk to render objects and elements. Render objects talk to widgets. Elements talk to widgets and render objects. And the pipeline owner talks to all three. Now, there's a very careful series of interactions between these objects, which is critical to implementing your Flutter UI. A test that puts widgets, elements, and render objects through their paces and verifies the correct order of operations, that would be a protocol test. On the positive side, protocol tests lock down the exact roles and responsibilities which implement critical behaviors in your app or package. With protocol tests, you can rest assured that particularly tricky areas of your code continue to do their job. Also, protocol tests run very quickly. On the negative side, protocol tests cover implementation details, which means the time invested in maintaining protocol tests doesn't necessarily have a direct connection to your product value. Also, protocol tests are only as effective as the encapsulation boundaries that define them. If your object APIs are poorly designed, then protocol tests are unlikely to help you. And finally, the last scope that we're going to look at today are unit tests. These are the most granular test scope that we can choose. There are many definitions floating around for what constitutes a unit test. For example, some people say that a unit test is a small test, or a unit test is a test that runs quickly. The problem with these definitions is that they have no consistency. What do we mean by small? What do we mean by running quickly? Ask 10 different people, you get 10 different answers. So this definition I don't find very compelling. There's nothing concrete at the center of these definitions. Therefore, the definition that I subscribe to is the one that says that a unit test is a test of a single method or function. A unit test controls all input to that method or function and therefore is able to verify all output and side effects from that method or function. On the positive side, unit tests are usually very short and simple, so they're easy to write and quick to run. Also, because you're only testing a single method or function at a time, you can write a suite of tests that exhaustively covers every reasonable input and output for that method or function. On the negative side, with such granular tests, you'll tend to write dozens or hundreds of unit tests for a single class. The maintenance burden can become costly. But now let's talk about test tools. We've talked about the most common testing scopes for app development. Now let's talk about the tools that are available for implementing tests. Developers often confuse test types with test tools. Test types apply to all app development or even all software development, not just Flutter or Dart. But the tools that we use to write tests are implemented specifically for Flutter and Dart. The test tools that Flutter and Dart provide are called integration tests, widget tests, and Dart tests. An integration test is a test that runs within your fully built application on a physical device, simulator, or emulator. On the positive side, an integration test is the closest that you'll get to your actual deployment environment. Your app will have access to real OS features like user location services, push notifications, and payment integrations. Your app will run at a real device aspect ratio with a real device pixel density, and as long as you run on a physical device, your app will run with an actual CPU, GPU, and memory constraints. On the negative side, integration tests are extremely slow. You have to build your entire app bundle before you can run a single test. Once your tests are running, the test runner on your computer has to communicate with the test suite on the device. Integration tests tend to run thousands of times slower than widget tests and Dart tests. Also, given that you probably wrote integration tests so that you could access real OS and network services, your integration tests will probably be flaky, which makes their long execution time even more costly because you might have to run them many times over. Then we have widget tests. The name widget test is a bit misleading. A widget test is not necessarily a test of a widget. In fact, it's rare to test a single widget. Instead, think of a widget test like a fake version of Flutter that's running on your computer. I say a fake version of Flutter because when you're running a widget test, various pieces of Flutter have kind of been turned off because they're not necessary. Or they've been replaced with fake versions so that the test runner can control the Flutter pipeline. For example, in a widget test, Flutter's clock only moves forward when you tell it to. This is a very important detail because you don't want your test actually running for the duration of every animation. I mean, if you have a 10-second animation, you don't want your test running for 10 seconds. You want to jump forward in time to the next point where something interesting happens. The only way to accomplish this goal is for widget tests to use a version of Flutter with some fake pieces. Now, on the positive side, widget tests run thousands of times faster than integration tests. When you're testing user interface details, widget tests are almost always the right answer. On the negative side, it's difficult or impossible to run asynchronous code like network requests, image rasterization, or reading and writing files when you're using a widget test. Finally, plain old vanilla Dart tests. A Dart test is the most basic testing tool available. Technically, integration tests and widget tests are both special versions of Dart tests. Dart tests are the most generic test that executes with the Dart test runner. Dart tests don't know anything about Flutter or devices. Dart tests are a good choice for implementing protocol tests and unit tests. On the positive side, Dart tests are literally the fastest available test tool. Also, Dart tests, in the absence of Flutter, can run asynchronous operations like network requests and file reading and writing. On the negative side, Dart tests can't help you lock down any of your wonderful Flutter UI. How about the goals of tests? Why are we writing these things? Why are we installing these chains? What specifically are we trying to answer? These are the questions that we're trying to answer. Is something wrong? That's kind of the highest level, the most coarse-grained detail. We want our test to tell us, is something wrong? Now, when I say wrong, again, this isn't like right versus wrong. Wrong in the sense that something was working one way and now it's working another way. Has something drifted? We want that signal. And then where is the problem? It's one thing to know that there's something wrong in your app, but where is it going wrong? Where should you look? Where should you begin the process of investigation and fixing it? And then finally, how do I fix it? We would like that question to be answered to the best degree possible, because if you know how to fix it, it's usually quick and easy to do so. Your choice of testing scope impacts the difficulty of finding the root of a problem. The more granular your test, like a unit test, the easier it is to locate the source of a problem. But it comes at the expense of writing a lot more tests. The more coarse your test, like a user journey test, the more difficult it is to locate the source of a problem, but you can lock down a lot more functionality with fewer tests. You can kind of see that charted here in front of you. The more granular we become with our test, the more specific we get with answering those important questions related to the purpose of our testing. This is a trade-off that you're making every day. This is part of what it means to learn how to write effective tests. Now let's talk about testing in practice. The biggest bang for the buck is user journey tests. You can capture the greatest variety of details with kind of the least amount of code when you're writing user journey tests, stepping from screen to screen to screen, entering text where you need to, pressing buttons where you need to, but making sure the user can get to where the user needs to go. This is where most apps should begin. Let's look at a kind of pseudocode example of a user journey test. Again, this is This is modeled after how you'd actually write this test, but this is not from a real app or package. This pseudocode test, in theory, is testing that a user can log in. We begin by pumping a widget tree. Think of this as initialization. We paint the entire UI for the screen at the beginning of the app. And often you will want to put some kind of expectation there to make sure that actually your initialization really did initialize. You might want to make sure that if you expect to begin at a splash screen or a welcome screen, that you actually are at the splash screen or the welcome screen. Now, in this hypothetical example, we're at a landing screen, and on the landing screen is a button to log in. And that button has a key it has a landing page loading button key. Make sure I get these names correct for you. So there's a button on the screen that has a key, landing page login button key. A long name, I know, but we find that key and we tap on the button. And then we pump and settle, meaning Flutter, go do all the animations, all the rendering, all the processing you want. And when you're settled, come back to us. And then finally, we have an expectation that says, can we find a key, which is called login page key? We tapped a button that's supposed to take us to login. Flutter does stuff. And now we verify that we are looking at the login page. That's what we've accomplished with these 3 lines. Then we look for a key for the username field for login. And we tap in the field, put the caret in the field so we can type some text. Again, we pump and settle so that the little animations that happen when you tap on a text field all complete. And then we type the text that you see here, user@test.com. That's the email/username. Then we tap on the password field and we type in some password that is going to work for our test. Then we press a button to actually do the login. Take the credentials, validate them, log us in. And then finally, we verify that we've reached the home screen. In our hypothetical app, these 3 screens, landing page to log into home screen, this is a user journey that we want to make sure works in this manner. And we've captured all 3 of those screens and the user interaction in this one test in about a dozen lines. Again, you get a lot of bang for your buck with user journey tests. What we didn't get here was any detail about, are we painting the right stuff to the screen? Do we have the padding and the margins and the sizes that we expect? None of that is covered here. Only the ability of the user to go through this journey. In practice, unit tests show us exactly where a problem occurs. To illustrate this, we're going to use a real test from the attributed text package. Attributed text is a package that we created as part of our broader super editor mono repo of packages. Attributed text takes a string and then allows us to place metadata in the string, such as, in this case, the concept of bold text. In this unit test, we create a new attributed text object and we initialize it with these spans. You'll see that these are spans of bold from character 4 to character 9. So the text between those 2 characters should have this bold attribution. And then we want to make sure that after we've created our attributed text, we can get the range back. So if we say, hey, attributed text, give us any bold range around character 5, it gives us back the range, and we expect that range to be the exact same range we created it with, which is a range from 4 to 9. We're testing our ability to query attributed text for the ranges of attributions. Now, here's the important thing to understand about this unit test. If it fails, it's going to fail right there. Get attributed range. That method is what's going to fail. That method contains the broken code or the changed code, the code that has drifted. The moment this test fails, we know exactly where to look. And this is one of the great values of unit tests. User interaction tests ensure that your UI is usable, meaning a user can do the things that a user needs to do. Here's a real example from Super Editor. This test is titled, tap down in focused field moves the caret. The first thing that we're going to do is set up the test. And this is, by the way, this is a common trend. Very often your tests will take the rough form of setup, method under test, verify expectations. Setup, method under test, or methods, verify expectations. So here in the setup, we pump our whole UI that has a text field, but then we tap on the text field to place the caret. And then we make sure that, yes, tapping on the text field actually did place the caret in the text field. Now with the caret at the end of the text in the text field, because that's where we tap. We actually tapped at the end of the text. But now we want to make sure that we can move the caret by tapping again. So we simulate a gesture where we tap down at the top left, which should move the caret to the beginning of the text field, which is what we verify down here. So still feels very similar to a unit test with the setup, just a few lines there to run the gesture and then expectations. But of course, we're essentially running an entire fake version of Flutter here, and we're simulating gestures. There's a huge amount of communication happening in the Flutter code behind the scenes. So it's not just our method and our code. We're running a bunch of Flutter code, which is one of the reasons that this is not just a unit test. Let's look at another example. This test inserts character in middle of text. Again, we start with setup. We render a text field to the screen. We actually give that text field some initial text. It shows kind of these two arrows pointing at each other in the text field. And then we place the caret right in between those two arrows. Our goal is to make sure that if we enter a character, it appears right where that caret sits, and the caret moves one character to the right. So here's where we type the code. We type the F character. And then after we type the F character, notice that our first expectation says that in between these two arrows is the F character. That's a side effect that we want and expect. And also, the second expectation says the caret has moved one character to the right because we expect the caret to sit after the F, not before it. Now, as an app or package grows, it tends to accumulate subsystems. Protocol tests identify object interactions that no longer meet expectations. Let's look at a real protocol test, again, from SuperEditor. Notice in this test, there's no pumping of widget trees. In fact, it's just a regular Dart test. It's not a widget test. It's certainly not an integration test. No widget trees, no painting, no Flutter. What we do is we instantiate these four related objects: a document which holds document content, an editor which knows how to change document content, a composer which holds the selection for the document or document layout, and then common ops, which is a whole bunch of very common document editing operations. And then we run this one method called delete selection. Now, I should point out, up here in setup, I've commented out the selection part of this because we need to fit this all in one slide. But we begin with part of a paragraph selected, actually across two paragraphs. And so down here, when we say delete selection, we expect a bunch of text to be deleted. Now, again, at first, you might think this is a unit test because we're just running this one behavior. But the whole point of this test is that this one behavior called delete selection will cause a series of additional calls between the document, the editor, the composer, and common ops. These objects all talk to each other. They're related. We're testing all of those little interactions here by calling this one method called delete selection. And then after we've run that method, we expect a few side effects. We expect that the document just has one paragraph instead of two because we deleted one of them. We expect that the paragraph that remains is paragraph number 2 with ID 2 because the one that we were supposed to delete was ID 1. We expect that the document has a selection and that the caret is sitting in that remaining paragraph and the caret is at the beginning of the paragraph. Those are all side effects that we expect once the document, the editor, the composer, and the common ops do all of their talking to each other in a kind of protocol. Now, one thing I want to leave you with when it comes to testing in practice is that user journey integration tests are the heaviest, slowest, flakiest, but also the deepest test that you can write. Let us go back to that initial user journey test. We saw this example a moment ago, but let's take another look. This test could be run on your host machine as a widget test with fake services, or it could be run on a real device with real services. If you run this test on a real device as an integration test, you'll wait a long time for your app to build, then you'll wait for your app to deploy to the device, and then any number of real device issues can break your test, even though you didn't cause those issues. Just think about, again, user location services, payments, even just the act of installing the app at times can fail for things like memory constraints. On the other hand, running this test as an integration test, when you press the login button, your app will log into your real server with real credentials. As a result, you'll have greater confidence that when you ship this app to real users, the app truly works in the most critical areas. So you do need to think very deeply about when you use integration tests versus widget tests. And you want kind of the fewest number of integration tests possible. But when you really care about how your app deals with your backend services or other non-UI technologies, integration tests are the option that you've got. With all this said, where can you go from here? You now understand that tests are not like quizzes, they're like chains. You write tests to lock down your source code and keep it from moving in the middle of the night. You've learned about various testing scopes and testing tools. What's next? Here are some things you might want to keep an eye on. You will likely get UI specifications that want different behaviors on different platforms. You might want to look into how you can accomplish that when you're writing your test. How can you have tests that verify different behaviors for different platforms? You may need to test against a variety of user interactions. This requires learning about Flutter's test gesture system. You'll end up concocting your own gestures. One thing that might help you is that we have a package called Flutter Test Robots, where we accumulate much simpler ways of expressing somewhat complex both gesture interactions and actually keyboards and software keyboard interactions with widgets. As you write your tests, you're going to start to see the same kind of widget tree setup and the same gesture implementations over and over and over again. Once you get to the point where you've got half a dozen tests that keep repeating these same pieces that aren't particularly relevant to that one test, look at converting common test setup and interactions into your own tools. Build out your own portfolio of testing tools. Also, partition your test files so that you can find what you're looking for. You're going to end up with hundreds or thousands of tests. So if you just want to know what's tested or what's not tested, how are you going to find the tests that you've already written? Obviously, when they fail, you can find them. But what about before they fail? What about when you just want to know what's already been implemented? You need to think through how you're going to segment your tests across files. And of course, run your tests on every pull request with continuous integration. They are only useful when they're running. Finally, I'll leave you with this. The art and science of testing is the selection of appropriately sized chains to lock down code that's vulnerable to drift. This is what testing is actually all about. And if you'd like to learn more about how to write effective tests, how to build open source software, consider subscribing to this channel, where from time to time, we will talk about how we build our various packages at the Flutter Bounty Hunters. And we'll talk about practices, philosophies, and tools that you can use to achieve better Flutter and app implementations on your end too. So y'all come back now. You hear?